Welcome back, everyone. Today we'll be talking about multiplying binomials. And if you recall from talking about not binomials before, they're just algebraic uh, terms. It's just two terms combined by either addition or subtraction, and each of the terms has to be either a number or a variable with and if it's a variable, it has to have an integer exponent, a positive integer exponent. Um, in order for it to be considered a binomial. So we'll be going through multiplying them. When you multiply binomials, goodness gracious. When you multiply binomials, we use something called the FOIL method, which stands for first, outer, inner, and last, which you'll see what I mean in practice with this. We can do a quick, example, and then we can go through the problems that we have because it'll probably be pretty helpful to do so. Okay, so if we think about first, outer, inner, last, or the FOIL method for multiplying binomials, say you have a plus b and a plus c. Okay. When we do this, when I say first, outer, inner, last, that's the order that we multiply in because we're essentially kicking up the distributive property a notch because we have to distribute both terms to everything in here. So when we do this, the first, I'm going to underline, or kind of box this in with this color. This is the first one. The two first terms get multiplied first, just to help you keep track. Next, we have outer, which means the two outside terms, the ones that are on the outer left and the outer right. And then inner would be the two inside terms, those ones. And then last refers to the two last terms, so these two. So that's the order you multiply in. So when we perform this multiplication, what you're really evaluating here is a times a, and then that was first, and then the outer would be, and you always keep like the signs that were in the middle. In this case, it was just two additions. It's just it's essentially like a harder version of the distributive property a little bit. The outers, so you'd have plus a times c. And then the inners, so that'd be plus b times a. And then the last ones would be plus b times c. So first, outer, inner, last, so that you know all of the terms got distributed, or got distributed to each other. So what we end up with when we simplify this, a times a is a squared, can't simplify ac, we just have plus ac, then we have plus ab, then plus bc. So that's how you multiply those out. You FOIL them, so to speak. And if you can combine like terms, then definitely combine like terms at the end. Okay, so now that we have that idea, let us go through these examples of multiplying binomials together. Okay, so it says s plus t times s plus t is equal to s squared plus 2st plus t squared. True or false? Okay, so we need to evaluate this and then see for ourselves. Okay, so we have, it's also good to note, I guess, here is a little segue. This is the same thing as saying the quantity s plus t squared. This is what we mean. You'd have to multiply them together in FOIL because you can't just distribute this power inside, because the two terms there, it's a binomial, it's separated by addition, so you can't just like put this power in here like this. You have to multiply it out this way. It's not necessarily included. It's just helpful to note that when you see something like this is what you have, or when you see something like this is what you have to do. Okay. So we have s plus t, and I'm going to try to stay consistent with the colors here to kind of illustrate the point a little bit. Okay, so we start with the firsts. That'd be s and s. Those are the first terms, both of the first ones. Then outer. Outer is these two. You multiply those two. Inner is these two. And then last, oh goodness, there it is. And then last would be these two. So when we think about this now, the first term is s times s. Outer is plus, oh goodness, that was disgusting. I'm sorry. That was not a letter. I don't know what that was, to be completely honest. Plus s times t. And the inners are plus t times s. And then the last would be plus t times t. So overall, we have s times s is s squared. We have plus st, ts, since multiplication is commutative, you can just switch the order, so that'd be plus st. It's usually conventional to write variables in alphabetical order when you multiply them anyway. And then t times t is plus t squared. So s squared and t squared can't be combined, but we have st and st, so we have two of those. So we end up with s squared plus 2st plus t squared, which that's exactly what they set up here. This one's true. Okay, so now we have negative, or it's saying that the quantity u minus 3v times the quantity negative 2u minus v is equal to negative 2u squared minus 5ub plus 3v squared. So we have to see if this is valid. Okay. So once again, our first terms first, we have u times negative 2u, outer, u times negative v, and then inner, and then the last one. Okay, so now let's FOIL this out. So the first one, we have u times a negative 2u. It's really important when you're doing this to keep the signs together. And then we have the outer. We have u times negative v. Since we're keeping the negative with the v, you can list this two ways. You can either say plus u times negative v, or minus u times v. It's up to you. I'm choosing to keep the negative with the variables just to avoid confusion. So we're going to say plus u times negative v. It helps when you FOIL, since there's a lot more terms, to just keep the signs with the variables that they come with and add everything together. It just makes it a little bit less ambiguous. Okay, and then we have the inner terms. So we have negative 3v times negative 2u. So we're going to have plus negative 3v times negative 2u. And then the last term would be plus negative 3v times negative v. Okay, so now we are going to multiply this all together and then see if there are any like terms that we can cancel. Okay, so u times negative 2u is negative 2u squared. U times negative v would be minus uv. Negative 3v times negative 2u is a positive 6uv. And then negative 3v times negative v is a positive 3v squared. Okay. Okay, so now we can combine some like terms. Actually, I don't need this. We have uv, a negative uv, and then a positive 6uv. So when we combine these, we have negative 2u squared. Oh my goodness. And then negative 1 plus 5. I'm sorry, negative 1 plus 6 is 5. So we have plus 5 uv plus 3v squared. So when we compare that to what we have up here, we have negative 2u squared minus 5uv plus 3v squared. So this one's actually false. It should be plus 5uv. All right, and that's the end for this one. I hope this one helps. Remember, if you have multiplying binomials, always FOIL. That's the way to go. It's what to do, and I will talk to you in the next video.